pull up next to Caitlin. Okay? I've only got that one left, Ryan. Okay. Oh, I did, Ryan. Sorry. You left it here. There it is. Okay. So let's do some non-chartables. Let's do a tan one. So these are non-chartables. But the same idea as solving for the chartable trig equations, okay? But these are ones that we won't find on our unit circle, so we have to use the concept of the unit circle, the cast rule, like play around, okay, where are our answers going to be? So I'm going to do 7 tan of theta, let's go minus 12, yeah. Minus 12 equals 0. So right away we don't have anything that we're used to looking at, a 7 and a 12. I mean, okay. But all the same rules go into it, just the end part looks a little different, okay? So we'll stick with degrees in this. We isolate tan theta by adding the 12 over and then dividing the 7 out, so I get 12 over 7. Okay. Now, my first answer, I'm going to always call it a reference angle. Okay, it might be our first angle, might not be. Okay, so in this case, I'm going to call it theta r. Okay, and I'm going to draw a little unit circle, kind of like we did before. So I'm going to put it over here. So I got my little unit circle, and I'm going to go with the cast rule here, like so. I recognize that the tan ratio here is positive, so I know that I'm going to get an answer up in there where the all are positive, and down in the tan is positive. Okay? So when we second function 12 divided by 7 tan, what do we get for that? For an answer? Make sure you're in degree mode. What do you get? 81.8 degrees. Okay? So that is up in here, right? So we're okay. So that is our first angle. Why I call it a reference angle is because if it was negative, it would be up in the sign, or be a negative, angle, and that's not really an angle that we want to use. So right away I can go theta 1 is 81.8 degrees. But there's a second angle still down here into the T quadrant there. How much? 180 plus, right? Because here's 180 degrees, and I want to go another 81.8 degrees further. So we add it, so we get 261.8 degrees. What is it? Sarah, you're fired. Let's try that again. Theta reference is what? 59.7 degrees. So again, it is still in the first quadrant, so we still call that the angle. So the theta 2 is still going to be plus the 59.7 down in there. So we get 239.7 degrees. Okay? So again, not any different than what you guys did before when we were solving those triangles, right? When we did ambiguous cases, it's sort of like that. Okay? We'll do another one, though, before we call her quits here. We'll do one that we have to factor and get a whole bunch of wild ones, maybe. Let's see. There's one. 15 sine squared. This pen's starting to really suck. Plus sine of theta, and then minus 2 equals 0. I'm going to switch over to that green maybe. I don't know if it's any better. I'll just take this out maybe. Okay, what kind of factoring is that? Hey? Trinomial difficult, yeah. What we like to call it trinomial difficult. So, here we go. What times what gives me a negative 30 that adds to give me a 1? It's going to work. 6 and negative 5, right? I knew you were on the right track, Kate. Okay? There it is. There's my splitter. So I'm going to split the middle term. So here we go. 15 sine squared theta plus 6 sine thetas minus 5 sine theta minus 2 equals 0. And then just GCF both sets of brackets. Now you notice though it's the exact same. Our sine theta is acting like our x now, right? That's all it is. So I can factor out a 3 sine theta out of the first one. And I'm left with 5 sine theta plus 2. And in this second bracket, I can just take out a negative 1 to make it the same. So if I factor out a negative 1, I'm left with a positive 5 sine theta plus 2 equals 0. And then I can group 5 sine theta plus 2. And then we're left over with 3 sine theta minus 1. So very similar to the quadratic equations, eh? Very similar. So set each of them equal to 0 and solve. So 5 sine theta plus 2 equals 0. 3 sine theta minus 1 equals 0. And when I isolate this first one, I get sine theta equals negative 2/5. And 3 sine theta minus 1, and solve that one. Add the 1 over, divide by 3. Okay, beautiful. Any questions? Pretty straightforward, eh? I apologize because it's so boring, but it doesn't get any harder. This is about as hard as I will give you guys. Except when we go to radians, but that's just the same stuff, only we're using a different measurement system, right? So tomorrow, like I said, we'll do that. Anyways, let's do sine theta, negative 2/5. So in your calculator, negative 2 divided by 5. I'll draw a little unit circle so we can get this all going. And I'll put the cast rule on there and everything. Beautiful. Sine is negative, so I know it's not going to be up here in the A or in the S. It's going to be down this way, and it's going to be down that way. So what do you get when you pump that into your calculator? Negative 23.6. So our reference angle is negative 23.6 degrees. And I don't really think about the negative so much, Robin. I just use it as, okay, I know where my angle's supposed to be, and I know how to get it there, right? So we know from the horizontal, I want to come down 23.6. So what am I going to do to get that angle? 360 subtract, yeah. So our theta 1 would be 360 minus 23.6, right? So 360 minus 23.6 degrees. So our first angle is going to be 36.4. Is that right? Think so? So there's our first angle. Our second angle, same idea. I don't think of the negative 23.6. I'm using that only as reference, and I know it's down from the horizontal into the T quadrant. So 180 plus the 23.6. So our second angle is going to be 203.6 degrees. So there's our first two non-chartables. And by non-chartable, I just mean not on the unit circle, because those aren't on the unit circle like that we can just pluck off like, you know, ducks on water. Sine theta is a third. It's positive now. So when I throw this on, I know up there and up there, because it's positive, where they're all positive and where sines are positive. So what's our reference going to be here? This is probably going to be our first angle, because it's going to show up in the A. 19.5. So that one works. That's good. So Theta 3 is 19.5 degrees. And theta 4 is going to be up. So 180 minus the 19.5. What's that going to be? 160.5? So there's our theta 4 and our theta 3. Any questions? Do you want me to leave you alone? That's as hard as it gets. I promise. I won't make it any harder. Good. Okay. Have at her, guys.